On some laboratory reports, if your instructor approves, you might find it easier to use Excel in order to create your own data tables. So I want to run through just a few ways to make your Excel data tables look a lot more organized and appealing, and kind of will get you past some automatic defaults included in Excel. So let's use the example of the free fall laboratory. So that was one where we were comparing the drop height for a marble to the time of flight. So let's make a data table that includes predicted height, actual height. I believe there were 3 time trials, so we can call it T1, T2, and T3. From those, we determined an average time. So we can call this TAVG. And then we also needed time squared. So we'll put time squared. Now I understand that this doesn't quite show up, but if I just highlight the top row and then I go to the alignment, I can change how the text is aligned from horizontal to vertical. And then you can see the full text. Now that might not be large enough font, so maybe we want to change that to 12 font. Perhaps center everything within the column. I can adjust left, center adjust, or adjust right. I think center adjust always looks good. If I need to make more room to fit in a longer description, obviously I can drag, but if I just double click, then it'll adjust to the longest text entry that's in here. Now, we actually don't want this to be T1. I want this one to be a subscript. So I can highlight the 1, go into font, and click on subscript, and notice that it changes the font accordingly. Likewise, with average time, again, AVG should be a subscript to the T, so we go into font and hit subscript. The 2 here is a superscript because this is T squared. So likewise, under the font pop-up menu, I can select superscript. Let me fix this T2 accordingly. Okay, so you get the idea. Of course, we might not need these column titles to be adjusted vertical because the text doesn't take up that much room. So we'll go back and align those horizontally. Okay, now let's make sure we enter our data. See, if I do a print preview here, notice that it has all the titles, but there's no actual grid. So we go back, we highlight this. Let's put in all of our values. Okay, so 10 centimeters, 20, 30, 40, 50, 60, 70, 80, 90, and 100. Actually, I want to insert a row so that I can state what the units of measurement are. Oh, and I want to include a 0. I think when it inserted that row, it copied the alignment from the row above. So let's go back and make sure this is all horizontally aligned. And let's choose all of our rows and columns and center align everything. Let's make all of our text, how about 14-point font? Okay, so here's where I want to insert a row. The predicted height is measured in centimeters. The actual height will be measured in centimeters. Time is in seconds, and time squared is in seconds squared. Again, I'm going to make sure that my subscripts and superscripts are correct, and fix the alignment. Okay. So now I want to put in some grid lines, so when I make a print preview, it'll show up a little more organized. So let's just click on all borders and see what this looks like. Okay, there we go. All right, so let me just fabricate some data here, and perhaps when you read the meter stick, well, I can add zeros all across the board. Okay, let me come back to this. No. Okay. It's made a mistake in this column. It's turned everything into a subscript. Okay. A little editing here, forgive me. That looks better. Okay, so let's say the actual height from 10 centimeters was more like 10.2, and 20 centimeters was 20.0, 30 centimeters was 29.9, 40 centimeters was 40.3, 50 centimeters was 50.0. Now notice when I type 50.0, it just goes right back to 50. Well, all this data hasn't really been identified as text versus number versus time versus currency. So it's all under general right now. All this data should be treated as numerical. Now, it made everything the same number of sig figs across the board. For our predicted height, since these weren't measurements, we don't really need any particular sig fig. So let's reduce this. Notice the tab I can click. Once this is identified as a number, I can click to add more sig figs or take them away. There we go. So I believe this column can be adjusted in the same way. And there we have it. Okay. 60.1, 69.8, 80.3, 90.3, and 100.1. Okay, so for example, if the times for 10 centimeters were 0.422, and 0.1422. Again, notice that it clipped off the number of sig figs. So I know for all of the times that the digital display gave 4 sig figs. So as I add the sig figs, notice that that 0.22 that I entered is still actually there. It's just when it was rounding it off, it had clipped it away. Let's adjust the column width. There we go. Okay, so perhaps the second time is 0.1425 and 0.1417. Okay, now I don't need to grab a calculator myself and compute the average. That's the power of using Excel to make the data table. If I highlight all 3 of the entries that I want to average, well, first I have to put an equal sign in the column that I'm trying to make a calculation for. So as soon as I hit equal, then Excel knows to look for some sort of a function, and average should show up in the pull down list. If not, you can click on more functions and you can describe what you're trying to do. So if we type in average in the description and hit go, then it brings us to the recommended function. So we'll hit OK, and now it's asking for which cell entries do we want. Now you could either type in here, or you can just go into the data table and highlight the actual cells. If we hit enter, then it calculates the average for us. Now here's the power of this one. Let's go to our 20 centimeter readings, and maybe our times are 0.1999 and 0.1982 and 0.1997. I don't have to enter that formula again. In fact, what I can do is use the Ctrl+C function on my keyboard for copy. Of course, I could also go under File and find Copy, but Ctrl+C is quick. And then if I highlight every entry for that column and hit Enter, it pastes in that formula. Now notice, because there are no quantities entered in for the 30 centimeter height, then it's trying to take an average of values that don't exist. So as you populate, the average will be computed for you. So for example, for 30 centimeters, maybe the time is 0.2466, 0.2487, and 0.2501. And then notice it updates the average in real time. Now we also want a column for time squared, which is the average value of time quantity squared. So we can enter another formula. Again, once we hit the equal sign, then it knows to calculate a formula. There may be a formula in here titled squared, but it would just be just as easy to click on F4, right? So we're column F, row number 4, and then squaring something is multiplying it by itself. So we can hit F4, multiply, and then click a second time on F4, hit Enter. And so it takes the value in that cell and squares it. Again, if we use Ctrl+C on our keyboard, that copies, and you know when a cell's been copied, it puts this sort of active border around it. So if we highlight all the cells in that row and hit Enter, it's pasted that function, and once again there are some cells that aren't calculated yet until we enter our data. Okay, so I'll fill out the rest of the data table and we'll skip forward to the next bit of instructions.